Morning, seventh graders. I hope that we're having a great start to our morning, but let's talk about math for a little bit. So, today's video is going to be all about scale drawings and scale factors. No, they're not drawing of actual scales, but they have to do very closely with what we've been talking about in terms of proportional relationships and other ratios and rates and other things like that. So, without further ado, let's get into the video.
Today, we are going to be talking about relating scale drawings to ratios and rates. And remember, this is all still dealing with what we've worked up to or what we've been working with up to this point. Same thing with proportional relationships, rates, ratios. But the important thing is that we're now dealing with certain drawings. And the first thing that I want to talk about is the difference between enlargement versus reduction. An enlargement is making an image or shape larger, whereas a reduction is making an image or shape smaller. I also wanted to bring up some vocab. A scale drawing are reductions or enlargements of two-dimensional drawings, not actual objects. So let's take a look at some scale drawings here really quick. For the following problems, A is the actual picture and B is the drawing. Is the drawing an enlargement or a reduction of the actual picture? Well, for the first one, I see that A is smaller than B, which means that B has to be an enlargement. For number two, A is larger than B, so that means that B has to be a reduction. Let me change that up a little bit, make it a little bit easier to read. A reduction. Let's move on to another problem. Derek's family took a day trip to a modern public garden. Derek looked at his map that was a reduction of the map located at the garden entrance. The dots represent the placement of rare plants. The diagram below is the top view as Derek holds his map while looking at the posted map. What are the corresponding points of the scale drawing of the maps? It's always important for us to really make sure that we are trying to look at our drawings from the same perspective. We can see in Derek's drawing right here that he has his map flipped in a different way rather than what the actual map is showing. So it's important for us to try to look and correspond what different points are. So I can see here for sure that A is going to correspond with R. I can look and see that point V is going to correspond with W, just based off of how I look at the pictures. Point H is going to correspond with point P, and point Y is going to correspond with point N. Again, it's always important for us to make sure that we are looking at our drawings in the right way, and sometimes that means we might have to rotate or look at it in a different view. Let's bring in a little bit more about this rate and ratio idea. Celeste drew an outline of a building for a diagram she was making, and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill the table below. So I know that for this first one, let's just call it for our original. This is the original, and this is the new. For my original, its height, it went from 0 up to 18. So it's 18 units tall. And it's 60 units wide. And then I know for my second drawing, it went to 9 units tall and 3 units wide. So I want to know, really what I'm trying to think of, is my scale drawing proportional to each other? So what I'm going to do is I'm going to label things as X and Y, and I'm going to see if it follows the same rate, okay? So 6 divided by 18, well, that gives me 6 over 18. I can reduce this, and it's going to give me, let's see, 3/9. And 3/9, or 1/3, sorry. And 3/9 also reduces to 1/3. So I know that since they both have the same constant of proportionality, that they are following the same rate. They are proportional. So let's go into our last example here. Luca drew and cut out a small triangle for a mosaic piece he was creating for art class. His mother liked the mosaic piece and asked if he could create a larger one for their living room. Luca made a second template for his triangle pieces. So let's fill out this table first. So I know in the original image right here, original versus new, the original image, it was 5 units tall and the width was 3 units wide. I know that the height of the new image is 15 units and the width of the new one is 10 units. So does a constant of proportionality exist? If so, what is it? Well, that means we need to try to reduce things. So does 3/5, well, that can't be reduced anymore. Does it equal 10/15? Well, 10/15 can be reduced. That equals 2/3. So they are not the same thing. So no, the K value is different. Okay, so they are not proportional to each other. Is Luca's enlarged mosaic a scale drawing of the first image? Why or why not? Okay. Well, in this case, since it's not proportional, no, it is not a scale drawing. In order for it to be a scale drawing, these side lengths have to be proportional, and these side lengths are not. Side lengths are not proportional. So let's go over our lesson summary. Lesson summary, scale drawing and scale factor. For two figures in the plane, S and S prime is what that's saying, the new S. The new S or S prime is said to be a scale drawing of S with a scale factor R, that constant proportionality, that rate. Okay, if there is a one-to-one correspondence between S and S prime, so that under the pairing of this one-to-one correspondence, the distance between any 2 points is related to the distance of the new corresponding points. A scale drawing is an enlargement or magnification of another figure in the scale, or if the scale drawing is larger than the original. A scale drawing is a reduction of another figure if the scale drawing is smaller than the original drawing. That is, the rate is between 0 and 1. So that is all that I have for you today. If you have any other questions, please feel free to leave a question in the comment section below, or you can message me on Schoology. But until next time, I hope that you have a great day.